transformations, this whole unit, is a really important concept in geometry. Okay, it's a really important OST concept too. Basically, a transformation takes an original shape, image, figure, point, etc., and creates a new figure through slides, which the formal word for slides is translations, flips, which are reflections, turns, which are rotations, and enlargements or reductions, which are dilations. In this specific unit, we are only going to talk about transformations that are rigid motions. Okay? And a rigid motion is a transformation that does not change the size or shape of a figure, but it does change its location. Okay, so a rigid motion takes a figure and moves it somewhere else in the coordinate plane, but it keeps the figure the exact same size and shape. Okay, doesn't make it bigger, it doesn't make it smaller. So the transformations we're going to talk about in this unit that are rigid motions, one is a translation. It's just a slide. You're just sliding the figure around the coordinate plane. You're not making it bigger or making it smaller by sliding it around. You're just moving. Another type of rigid motion that we're going to talk about in this unit and today is a reflection. Again, a reflection is you're just flipping a figure over something. So when you flip a figure, you're not changing its size, you're just taking it from one spot and flipping it over to another. So it's just changing its location. And the third type of rigid motion that we're going to talk about in this unit is a rotation, which is just, again, a turn. You're just turning a figure around the coordinate plane. You're not changing the size. A transformation we're going to talk about next unit that's not a rigid motion is a dilation. We're not talking about it this unit, we'll talk about it next unit, because dilations enlarge a figure or they reduce a figure. They make a figure bigger or they make a figure smaller. Changes the size. So that's why it's not a rigid motion, because that's exactly what a dilation does. It changes. Okay. So these three we're going to talk about in this unit. We're going to talk about these two today. Okay. Question. And the reason why we're talking about translations and reflections together, because if you can count, you can do a translation and you can do a reflection. Okay? Or not that bad. If you can count, you can do this. So a translation, first type of transformation we're going to talk about, is where a geometric figure will shift, not shift, do not catch that, or slide, however you want to think of it, left, right, up, down, or a combination of the two. Okay? It will have some sort of horizontal movement along with some sort of vertical movement, or it might just move horizontally or it might just move vertically. Okay? It's just sliding around. In any transformation, doesn't matter if we're doing a translation or a reflection, the starting figure, the original figure, I gotta orient this board, is called the preimage. So the original figure is called the preimage. It's what we start with. So in this diagram, this triangle right here is our preimage. Okay? I'll explain to you in a second how to notice the difference. After you do your transformation, your resulting figure, your answer, is what we call the image. Okay, can you put your phone in this? Okay. So the figure you start with, the figure beginning, is the preimage. After you do your transformation, your answer is the image. And we know the difference because the image has little tick marks on it, prime marks. Okay? So I know this one was my pre-image because there's no prime marks. We do a translation to it, and this is my image because it has those tick marks, it has those prime marks. So that's how you indicate the difference between the two. Okay? You have to put those little prime marks on your answer to indicate the difference between the two. Okay? diagram at the right that we just labeled shows a translation. You can see that the triangle shifted left 5 units, so each vertice went left 5 units and then up 2. This went left 5 and up 2. A went left 5 and up 2. Okay? The rule for this translation can be written as follows. Okay? A lot of times when you're told you have a translation, it doesn't say, hey, do this translation. It's just written in this notation. You have an X, so kind of like a coordinate with an arrow. Then you're going to have parentheses. It went left 5 units. To indicate that it went left, it would say X minus to indicate you went left, however many units you're moving. So X is always your horizontal shifting. Think the X-axis is horizontal. So anything with X is going to move left or right. Minus means you went left. Adding means you go right. To indicate that you went up, we would put Y plus 2. Anything with Y is your vertical movement. So up or down. Again, minus, you go down, add, you go up. Okay. Questions over that? Okay. So here, if we take a look at this example, it says graph the image of the figures graph below using the given transformation. Whenever you see the wording like that, it says graph the image, all that's saying is like, hey, do this transformation. Because your answer is the image. Okay? So we take a look at A. I have this coordinate with an arrow. We're adding things to X, we're subtracting things to Y. So that's telling me I'm doing a translation based off that notation. Sometimes it is written out for you in a sentence. Sometimes, most of the time it's going to be in this notation. So based off what they have written, what directions are we moving? If it's X plus 5, that's saying we're going where? We're going right 5. Yeah, we're going right 5. Then it says Y minus 2. So then what direction are we going to go? It's a little down 2. Good. Y is always your vertical movement. X is always your horizontal movement. So that's all you're going to do. You're going to take each vertice of this triangle, move it right 5, 1, 2, 3, 4, 5, and then down 2. Put your point, label it A prime to show that it is the image. Do the same thing with C. It's going to go right, 1, 2, 3, 4, 5, down 2. Label C prime. Same thing with B. Go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Down 2. Label it B prime. And you need to label your points with those prime marks. And as you can see, it's the same exact triangle. The size of it didn't change. The type of triangle didn't change. It just slid over and down a little bit. That's the translation. Just sliding the figure around the coordinate plane. If we take a look at B, again, I see things are being added or subtracted to X and Y. So that's telling me I'm doing a translation. What direction are we going? First, if it's X minus 3. X minus 3, we're going to go where? Up, down, left, right. X minus 3. Oh, yeah, we're going left 3. And then we have Y plus 1. So which direction are we going to go? Up. Just go up 1. So each vertex is going to go left 3, up 1. Label. Left 3, up 1. Label. Left 3, up 1. Label. And again, it stays the same exact triangle. It just kind of slid over and up. It's changed its location. Questions on that? Not too bad. Translations, I think, is the easiest transformation. You're just sliding, counting. And if you can count, you can do this. You just have to remember X is horizontal, Y is vertical. Questions on that? Okay. Flip it over. We're going to talk about reflections. A reflection is a type of transformation in which a geometric figure is flipped over a line of reflection. So whatever you're flipping your figure over, that's called a line of reflection. And you're always flipping it over a line or an axis. In a reflection, the preimage, which again is your original figure, and the image, which is the resulting figure, have opposite orientations, and each vertex of the image is the exact same distance from the line of reflection as the preimage. So the two figures have opposite orientations, and they're the same exact distance from the line of reflection. Okay. Knowing this, let's do some reflection. Okay, we're graphing the image of the following figures. We're just doing these reflections. First one is we want to reflect it over the x-axis. So what I find helpful, I'm going to highlight the x-axis. And we said the pre-image, the starting figure, and the image or answer is the same exact distance from that line. So all you have to do is pick one of the points. We'll start with K. And count how far it is away from that line. How far is K away from our line of reflection? 1. So then count 1 away from in the opposite direction. And there's K prime. Again, they're the same exact distance apart. So do the same thing with N. How far is N away from our line of reflection? N is 1, 2, how far? 3. So then you just go 1, 2, 3 in the other direction. Do the same thing with L. L's 1, 2, 3. Count 1, 2, 3 in the other direction. There's L prime. And then M, how far is M away from that line of reflection? 5. You just go 1, 2, 3, 4, 5 in the other direction. There you go. They have opposite orientations. You can see M's pointing up, M prime's going down, pointing down. And they're the same exact distance away from that line of reflection. So again, if you can count, you can do a reflection. Not that bad. So to take a look at B, I think the hard part about reflections is graphing lines correctly. Sometimes we get mixed up how to graph those lines. So we take a look at B. We want to reflect this figure over the line y equals 1. So I'm going to go to where y is 1. Y-axis, go to 1. Here's the tricky part. What type of line are we going to draw through that point? Are we going to draw a horizontal line or a vertical line? Horizontal, very good. Think it has to go the opposite way of the axis. If you went vertical, you're highlighting the y-axis. That's not what we want. We only want a line where y is 1. So think opposite of what axis it's on is the way you're going to draw your line. Okay? So we're just taking that figure and we're reflecting it over that line. Okay? So do the same exact process. Pick a point. Count how far away it is. S is 1. So you count 1. T is 1. Count 1 in the other direction. V is 1, 2, 3. Count 1, 2, 3. U is 1, 2, 3. 1, 2, 3. And there you go. Make sure you connect your points too. Don't just leave the points and label. And then they're flipped, opposite orientation, same distance away. Yes.
We don't label like the points when we points taken off.
Yes. You gotta label. So because sometimes you're just given, you might not be given the figure, you might just be given, hey, this figure has these coordinates. And if you don't label, I don't know which one you think it is. Like, did you just label your points? Like, so you have to label. And on the OST, some questions, they make you like drag and click the labeled points. So if you don't get in the habit of doing it now, you might forget to do that on your OST. So just label. Get in the habit of that. That's a good question. take a look at the last example of this, last one of this example. We're going to reflect over the line x equals -2. So I'm going to go to where x is -2. Okay. And I'm going to draw a horizontal line or a vertical line. Vertical. Opposite of what axis is on. It's on this axis, so I'm going to go this way. And if we went the other way, we're highlighting the x-axis, and that's not what we want. So then do the same thing. Just count. That's not going to show for you. I'll do these 1, 2, 3. Count 1, 2, 3. A is 1, 2. 1, 2. Here's the thing. What about B and C? How far are they away from that line of reflection? Yeah, they're sitting right on it. So are they going to move at all? Nope. So you just label it C prime, B prime. Sometimes that happens. When a point's sitting on the line of reflection, it just stays there. Questions over that? Okay. One special type of reflection that they like to ask a lot is reflecting over the line y equals x. Love to ask it. Okay? So it's an important one to know. To do that, and this, we'll only do A and B. C, if we can do A, you can do C. To reflect a figure over this line, we have to draw that line of reflection. And then I'm going to show you a shortcut that might be easier, just in case you forget how to graph this line. Okay? To graph the line y equals x, it's like the first line you probably ever graphed. Most basic, so think back to like maybe your pre-algebra days to graph this line. Think y equals mx plus b form. Is there a y-intercept? No. So where do we start at when there's no y-intercept? 0. Okay, so we start at the origin. And then what number is in front of the x? A 1. So what's our slope? Just up 1 over 1. Right down the middle. And then you go the opposite way. You go down 1 over 1. So you start at the origin, and it's going exactly right down the middle of your graph. That's y equals x. So we're reflecting this figure over this line. Okay, you graph it that way every single time. Y equals x. Every time. That's how you graph that line. To reflect over this line. Okay? Remember, when we reflect, we're taking the figure and flipping it over that line. So visually, when I look at this and I flip it, okay, I take this figure and flipping it over this line, it's going to end up somewhere in this area, visually. I don't know exactly where quite yet, but visually, my answer should end up somewhere in there, right? You flip it, it's going to land. So we're still going to count, just like we've been doing. We're still going to count. I'm going to take S. And when I count, 1, 2, 3, 4, 5, 6, 7. And I always count up or down first. Okay? It's 1, 2, 3, 4, 5, 6, 7 away from that line. It's 7 away. So I'm going to think. My goal is to land in this blue area. Which direction do you think I'm then going to count to get it in that blue area?
Right.
To the right. So you just go right. 1, 2, 3, 4, 5, 6, 7. That's for S prime before the right. And you do the same thing with all the other points. See, when I count, T's 1, 2, 3, 4, 5. So which direction am I going to go to get in that blue area? To the right again. 1, 2, 3, 4, 5. Same thing with you. Use 1, 2, 3, 4, 5, 6. Get it over there. I'm going to go 1, 2, 3, 4, 5, 6 to the right. And then V's 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to go right. 1, 2, 3, 4, 5, 6, 7, 8. And we're done. landed in the right area. We took this figure, flipped it over that line. Questions over that? Okay. If we take a look at B, again, we're reflecting it over the line y equals x. We plot the line the same exact way. We start at the origin, and go up 1 over 1, right down the middle. And it's totally fine that your line of reflection is going through the figure. Sometimes that happens, and it's totally fine. Okay, don't think, oh no, it's going through it. I have to graph it differently. Nope. Graph it the same way every time. Some students, it's like going through the figure, they're like, oh no, and then they graph it this way. Don't do that because it's a totally different line. Just graph it the same way every time. Okay? And then we just count. So I'm going to start with E. Again, I move up or down first. So to get to the line, I'm going to move up 1, 2, 3. Well, again, visually think. I'm flipping it over this line. So I went up 3. Which direction do you think I need to go? Left 3. Okay, same thing with G. G, I went up 1, 2. Which way do you think we're going to go? To the left 2. And then F, this time around, which direction are we counting first? We went down 3, so which direction do we think we have to go? Right 3. So you don't always go the same direction with each point. You do when the point's above, when the figure's above or the whole figure's below, then everything's going the same direction. But when it's going through, some things go up and left, some things go down and right. It just depends. And then connect. And there we go. We flipped it over that line. Questions over that? And again, we won't do C. C is just like A. So the figure's below 1. So the concept's still the same. There's a shortcut to this. Okay? If you like, I'm good with that, I can just graph that line every time, count that same way, I'm good. Okay? Sometimes we forget how to graph the line y equals x stuff. It just happens. We're humans. Like, I forget things all the time. Okay? So if that happens, here's a shortcut. What we're going to do, we're going to go to B. And we're going to write down all the pre-image coordinates, so the starting coordinates. So what was the pre-image point E? What were the coordinates of that point? Of E. Good. 4, 1. And then EF. Where was F located? Good. -1, 2. And then where was D located? -1, -3. Okay. Those were the pre-image points. So we're now going to write down the image coordinates. Where did E prime end up being? 4. Where was F prime? And where was D prime? What do you notice? You just flip it. So if you come across the line, reflect this guy over the line y equals x. If you're like, oh darn it, I don't remember how to graph the line y equals x, and it happens, trust me, or you think you remember, you're not sure, that's okay. Just remember, shortcut, flip the point. Just write down all the original points, flip them, and there's your answer. Just plot. So whichever way works for you, okay? There's no right or wrong way. This is kind of, I like to think of a backup plan, just in case you forget. But a shortcut is just switch the x and y values of the preimage. Let's flip the points. 4, 1 became 1, 4. Just flip it. Some of you might think that's easier than graphing the line and counting. Totally fine. I don't care which way you do, as long as you get the right answer. Questions over that?